Let's write a script to plant whatever we want on command. Go ahead and attach Cheat Engine to the game and let's get started. You can do this on any adventure level, but ideally you want to have at least a few different plants unlocked. Select whatever loadout you'd like and start the level. Before we get into the script, I'm going to make a sun hack and also a plant cooldown hack, because we're going to need to plant a lot for this script. For the sun hack, simply search for your sun using an exact 4-byte value, then plant something and search for the new value. You should find it pretty easily, and then you can change the value to give yourself a bunch of sun to work with. Next, for the plant cooldown hack, change your scan type to unknown initial value, and leave your value type set to 4 bytes. Focus on just one of your seed packets. In this case, I'm doing the sunflower. As the cooldown changes, search for a changed value. Once the seed packet is full, search for another changed value, and then finally afterwards search for an unchanged value. Then, use the seed packet once more, and again search for a changed value. Keep doing this until you narrow it down. Once you find it, it'll be pretty obvious because it's going to be a 3-digit number that's constantly increasing. You can freeze the value like I did to make sure that you found the right one. As you can see, the seed packet's cooldown stopped changing, so I know I found it. Finally, you can right-click on this value, find out what writes to it, then click on this first pop-up, show disassembler. Then without clicking anything else, go up here to Tools, Auto Assemble, and AOB Injection. Now if your code is different than mine, you probably found the wrong value, so go back and try again. Otherwise, make the exact changes I do. I'm not going to go in depth about why this script works because we have way bigger fish to fry. But for now, just make the exact changes I did and assign it to your cheat table. Go ahead and enable the cooldown hack and make sure it's working properly. And if it is, we can finally get started. Alright, so the first thing we need to do is actually find the function in the game's code that's being called every time we plant something. Unfortunately, this is going to be pretty goddamn tedious. Let's go ahead and right-click the value of our sun and find out what writes to it. Now, immediately after planting something, you're going to notice a pop-up. Go ahead and click this one and hit Show Disassembler. It should be a move instruction. If it isn't, you're probably looking at the wrong pop-up. Now what you're seeing here is assembly code, x86 assembly to be specific. Now unfortunately, assembly was designed for cold-hearted, soulless machines, so it's pretty hard for us lowly humans to read. However, we can still get some hints about the structure of the original code by inspecting it. As you can see, we've got a sub instruction, which means some subtraction is going on. This is probably subtracting the amount the plant costs from our total sun. However, other than that, not much else is going on, which means this is likely a dedicated sun subtraction function being called by a greater plant function. If you're not very familiar with programming, you don't have to worry about this, but this is likely what the structure of the code looks like. It performs some checks to make sure we can actually plant whatever we're trying to plant, then it subtracts the cost from our total sun, and finally it runs some finalize function that actually plants. Of course, this is just my best guess, so it's definitely not 100% accurate. Assuming I'm correct, we're looking at the subtract function right now. What we need to do is go up a level to the plant function and finally find the finalize function within it, because that's the one we're really concerned with. To do this, we're going to select the line of code in this function. Any of them should do, but if you want to be safe, you can do the same one as me. Now hit debug and toggle a breakpoint. A breakpoint essentially stops the program whenever this line of code is run. And also, useful for our purposes, it's going to tell us where this function is being called from. Once you have the breakpoint toggled, go ahead and plant something and your game should pause. You should also see some stuff pop up at the bottom right of the memory viewer. That first address is likely going to take us to the greater plant function, so go ahead and double click it. Before you do though, you can also untoggle this breakpoint because we're not going to be needing it anymore. This function is a lot bigger than the last one. Another hint that what we found is the greater plant function. Go ahead and hit run, set another breakpoint here and plant something. If you did everything right, the game should once again pause. Now, finally we can sift through this function and find the finalize function. Function calls in assembly are denoted by the call instruction. Now scrolling up and down, you might notice an issue. There are about a goddamn billion of these. Luckily, we can ignore the vast majority of them. We're looking for a function that has a lot of parameters, and in assembly, to pass in parameters to your function, you need to use push instructions. What this means for us is we need to look for call instructions that are preceded by a bunch of push instructions. For example, if you scroll down just a little bit, you might notice Plants vs. Zombies plus FCA0. And as you can see, there are push instructions before it. Go ahead and right-click this function and hit follow. Then put a breakpoint on the first line of the function. Now, if you run the game, what you'll notice is that the breakpoint is constantly going to be triggered. What does this mean? Well, this function is being called a lot. We're looking for a function that's only being called when we actually plant something. So, we can safely assume that this isn't our function. Go ahead and disable this breakpoint, right-click the first line of the function and hit back. I kept scrolling down and eventually I found this function, Plants vs. Zombies plus FA10. Again, a function preceded by a bunch of push instructions. Let's do the same thing. Follow the function, put a breakpoint on the first line, and bingo! The game only pauses when we plant something. Therefore, this is most likely the finalize function we were looking for. Now, as you can see, before the function call, it's pushing EDX, EAX, ESI, and EBP in that order. What are these? They're registers, and they're used to store and move data. Basically, they contain the parameters the finalize function needs, like the type of plant we're placing, where we're placing it, etc. The issue is, we have no idea what data is being stored in each of these registers. In order to figure this out, I'm going to toggle a breakpoint on this line of code, and I'm going to do some controlled experiments. I'm going to plant the sunflower in the first row and column. I'm going to place the same plant in the same row but one column over. As you can see in the top right, the only register that changed, indicated by the red, is ESI. We can safely assume that ESI stores the column the plant is being placed in. I'm going to keep track of this in a notepad so we don't forget. Now I'm going to place a sunflower in the same column but a different row. This time EAX is the only one that changed. Therefore, EAX is likely the row the plant is being placed in. And finally, I'm going to place a different type of plant in the exact same spot as the last one. And as you can see, EBX is the only register that changed, so it's likely referring to the type of plant. Alright, now it seems like we have all our parameters understood, except what in the world do EDX and EBP do, and why is the function using them as parameters? Well, taking a look at the top right, EDX seems to just contain -1 in hex. As such, it's likely some sort of flag or condition the function uses, but since it doesn't change, it shouldn't be an issue. However, EBP seems to contain a seemingly random number. If you scroll up a little bit though, you'll notice that EBP is used a lot, and it's usually EBP plus some offset. If you've ever written scripts for Cheat Engine before, you might recognize this since this is a super common pattern. Games will oftentimes have a base player address, or whatever object we're looking at, and the attributes of said object will be some fixed offset from its base address. Therefore, the value stored in EBP is some sort of player ID, whatever is at the player's base address. Now we could just copy-paste this value, but the issue is, the player's ID is going to change every time you restart the game. So if we want to make a script that'll always work, we're going to have to get this player ID every time we turn on the game. This might seem cumbersome, but we can actually write a script to do it for us. I'm going to scroll to the top of the plant function. Not the finalize function, but the greater plant function. Go ahead and select this move instruction, and let's do an AOB injection. Now here, I'm going to allocate a custom variable. To do this, we're going to use the global alloc keyword. Call it player ID and allocate 4 bytes for it. I'm going to set its initial value to be equal to 0. Then finally, I'm going to edit the code to set the player ID equal to whatever is stored in the EBP register. This can be done with a move instruction, where moving the data from EBP to our player ID variable. Go ahead and assign the script to the cheat table and enable it. Hit add address manually and put in the name of our variable, in this case player ID. Finally, go ahead and plant something and you should notice your player ID's value changed. Double click the value type and toggle the hexadecimal option. Now we can clearly see that it's the same thing that was stored in the EBP register. Finally, we've got everything we need so we can start writing the script. Hit Memory View, Tools, Auto Assemble, and let's get to writing. Now upon enabling our script, we want to allocate some memory. Normally, we'd want to edit code that already exists in the game's memory. However, in this case, we're essentially writing our own fresh code. I'm going to allocate 2048 bytes. This isn't some specific number, but it should ensure that we have enough for our code. In fact, it might be a little overkill, so you can tweak it a little bit if you'd like. I'm going to begin by initializing our parameters. Remember, EAX is the plant's Y coordinate. I'm going to set it to 0 initially. I'm going to do the same with ESI, which is the plant's X coordinate. I'm going to set EBX to 1, and remember this is the type of plant we're placing. Finally, I'm going to set EBP equal to the player ID variable we allocated earlier. Then, I'm going to push the parameters in the same exact order the game did. That is EDX first, then EAX, then ESI, then EBP. And finally, I'm going to call the finalize function, which remember was Plants vs. Zombies plus FA10. Then, let's put a return instruction after our code, and remember to deallocate your memory upon disabling the script. You can now add the script to your cheat table. One last thing, we need to create a thread for this code. A thread is a branch of the program which can be executed in parallel with other threads. This means that our script can run concurrently with the rest of the program. I'm going to give it 1000 milliseconds. Again, not a super specific number, but this should be enough. Now, finally, if you activate this script, we've done it. We can plant stuff on command. In fact, you can plant whatever and wherever you want, including on top of other plants. Look at him, isn't that cute? All cuddled up together. Now right now, if we want to change the type of plant we're placing, or its X and Y coordinates, we'd have to go into the script every time and manually change it. Now you can do this, and it works just fine, and I even encourage you to try changing the plant ID and see what kind of goofy plants you can find in the game's code. But for practical use, this is going to get really tedious. So, in the next video, we're going to take a look at how we can allocate custom variables for all these parameters, so we can change them on the fly, and how we can even plant multiple plants at once. But for now, thank you so much for watching. If you enjoyed this video or learned anything, let me know, and peace out.